We're in analytical geometry. We did a few things extra, namely the inclination. If I get into a sketch and I want the inclination, that's when you'll know to work with. An inclinations formula is, which means it's got to be a straight line, obviously, of which the gradient will bring me to the degrees. And the only way that the inclination can work is either I've got a negative gradient and the inclination is going to be an obtuse angle, or I've got a positive angle, which is not on the board. However, that will then mean it's going to be an acute angle. But you need the gradient. Gradient gives you the inclination. Alright, so that's the new word. Let's go to a few interesting things. If I told you, and this was last year's work, if I asked you for angle B, point D's coordinates, can you just get them for me like that?
Yes.
Yep. How? Transformation or translation. Because the same thing that's happening from A to D will be happening from B to C. If I tell you, not just this, I have to tell you that ABCD is a parallelogram. Then the translation works, not for anything. Because if it's any random quadrilateral, I don't know, the lengths between the sides don't stay the same. But because it's a parallelogram, the same translation that takes place from there to there, please sit still. Same translation from there to there is going to take place from there to there. Same translation from there to there will take place from there to there. And any which way I want to name it now, you've got to choose one. So I'm trying to find for D. So I'm saying, if the same thing that happened from B to C happens from A to D, what do I need to do? From B to C, I did what? Negative 2 became 6. So what does that mean? 8. Adding 8 to the x coordinate. Add 8 to the x coordinate. 5. And you get? 5. Just like that. Okay? And the same thing that happened to this y. What happened to this y? Minus. It's minus with 2. Down with 2. Should happen there. Down with 2 will give you. And that's the answer. So if the question just said find D. Now guys, there's a lot of ways to find it. You can get the equation of these lines. This line's equation. This line's equation. Gradient here, gradient there, and work with it backwards to gradient. But that's the easiest way, is to know that it's a translation when it is a parallelogram. That includes if it's a rhombus, right? That includes if it's a square. Because all of them are still parallelograms. Let's get into that discussion again. Is a parallelogram a square? No. But is a square a parallelogram? Is a rhombus a parallelogram? Is a square a rectangle? No. Yeah. The essence of a rectangle is opposite sides are equal and the angles are 90. Is a square a rectangle? Yes. Yep. This extra, all the sides are equal, but the essence of a rectangle, opposite sides are equal. But in the case of a square, they're all equal, but it still makes it under the big frame of being a rectangle. What does that mean? Everything you know about the rectangle applies to the square as well. Are you with me? So the diagonals will also be equal, just like in the rectangle. The lengths of the diagonals are the same. That's why it's a rectangle. So if it's a rectangle and all the sides are equal, that makes the rectangle a square. Okay, you've got to know your stuff, because this is going to come into play with the combination exercises for analytical. You've got to know those things. I love asking that. So let's do it the other way. See if we get the same answer. We said from here to there is the same as from there to there. Let's check it out this way. So from minus 2 to negative 3 should be the same as from there to there. Do you agree? Yes. What happened from minus 2 to minus 3? Yes. 1 left. So go. 1 left. Also gives you 5. Are you with me here? What happens from negative 4 to 7? That's up with 11. Up with 11? Do you have to explain yourself? No. I would like it if you said with translation. Because that's what we are trying to teach the kids now to do in the markers as well, to look for that. Because there's lots of other ways, huge and long ways, but you're going to get 2 marks for that. Okay, just a little something extra in there. So I'm saying, please remember all of the properties of your squares and rhombuses and parallelograms. And in essence, remember that all of them fall under the big overseer of parallelogram. Under the parallelogram is the rectangle and the square and the rhombus. All of them are still in essence parallelograms, but not every parallelogram is a square. Not every parallelogram is a rhombus. So if I ask you to prove it, you've got to get enough information. Knowing that all the sides are equal, does that make it a square? Or not a rhombus? Only knowing that all the sides are equal is just enough to say that it's a rhombus, not a square. For a square, what do you need? More. You need a 90 degree. Are you with me? You cannot just make a deduction. You've got to have enough information. All right. So this is a nice hint to remember. Let's look at another example about inclination. If this was your sum part of other things on a sketch, because they like giving you a big sketch and then asking you sums, we'll do one like that now. If I ask you for the equation of this line, first of all, you should know that it should be, so please remember that ma'am is always saying, please know your straight line, because you are using it in algebra equations and functions, you're using it in analytical, and you use it in trig. So if you choose not to know the trig, to know the straight line, how silly are you if you get asked everywhere about it? Okay, so the straight line. Okay, but ma'am, let's work out the m. Ooh, how do I work out m? I don't have 2 points. What has been given? The angle of inclination. How does that help me? You're going to get a mark for knowing that you're busy with this whole thing, but you now know the angle. So how do you get to the m? Shift tan, normal tan. You've got the degrees, you want the ratio, and the ratio is the m value. Answer?
-0.
Say again?
-0 plus 70.
Okay, 145? Oh, I'm on the wrong thing, sorry. Yeah, so, sorry again, negative? 0,7? Okay, so let's just make it 0,7. I hope the people in the test would have said round off to 1 decimal. So, if that's my gradient, how far am I from finding the equation? Y is equal to negative 0,7 x plus c. Normally we don't work with decimals, but so be it. Now I still need the c, and for that, like everywhere, we need to substitute a point, and that's why that measly point, -1 and 3, has been given. So we substitute the 3 into the y, and we substitute the x with a -1, and we solve for c plus minus 2,3. Please check me. Right? 3,7 plus, but this is plus. And then minus. How do you get 3,7? Minus times a minus is a plus. It becomes a minus. Okay, please don't forget to answer the question. After finding C, you should know, you should write down your equation. Don't forget to actually give the answer that they were asking for. Does it kind of like look right on the sketch? Negative gradient? Yeah, has to be. What does this mean? That's the y-intercept. Does 2,7 look right? 2,3 look right? 3 less. Are you with me? So if you had gotten 3,7 like you guys were telling me, 3,7 can't be. There's 3. How can this be 3,7? Then you know you made a mistake. Go check where did you make a mistake. Alright, let's get into mixed exercises. There's no inclination in the sum, but let's quickly look at it. Sum has been given, and I'm asking you for M. M is a point. Please note, capital letters and small letters don't work the same in maths. You can't decide to make your gradient a capital letter. Capital letters are points, and gradient M has got to be a small letter. So if I talk about gradient of Mn, then Mn as capital letters, it's 2 points. Alright, just be sure of that. And say for instance, I asked you for find M. Did I ask you for the point M? No, I'm talking about the gradient. So it's very essential that you look at this stuff correctly. Like in the parabolas, they would ask for small a, b, and c. That didn't mean that capital A, B, and C was something else. Okay, take a look at that. Make sure you work that specifically. If I ask you for M, now in the reading there they said that this is the midpoint of AB. Would that be easy to go find? Okay, do it. Gradient of MN. Would that be easy? Now just have found this one in the previous question, but get MN's gradient.
We don't have animals.
You only have 1 point. What else are you missing? O, it's not through O. Parallel lines. This gradient, which I can't find because I don't have enough information, will be the same as that one. So work out this one's gradient. You see how you must think about it? Okay? Then you must find the equation of Mn. Would you be able to do that now?
Yes.
Because once you've got the gradient, you can find the equation because you need a point, which I have, M, from the start. Then they're asking me for N, which is another point. Would I be able to find point N? Okay, you're going to have to think about it. Let me give you some hints. Don't you see the grade 10 theorem here? Not necessarily going to have to work that way. But don't you see the grade 10 here? What about grade 10? The what theorem? The midpoint theorem. In a triangle, if that side is drawn equal to one of the sides, and it's in the middle of that side, this one will also be taken into 2. Are you with me here? So this will also be equal to that. So what does that tell me? M should be the midpoint. And I'm starting to think all sorts of weird and wonderful things to go and find out. Now you can, but if you knew that, then N would just be simple, find the midpoint. How do you know that? Midpoint theorem. If that's parallel and that's equal, then this has to be equal as well. So N is actually the midpoint. Then it's going to be 2 marks, and you're going to think, yes, like I've got to do lots of work. Because you can find the grade, the equation there you have. Find this one's equation, because N is where they intersect. And you go and you put them into each other, and you look at the marks, and they say 2 marks. All that work. Well, you're going to get your 2 marks, but for not more work. If you did realize that. Okay, that's the main thing that you take over from grade 10 geometry. Then they're asking me the question that I just showed you. If A, B, C, D, A, B, C, I don't know D. If A, B, C, D is a parallelogram, where's D? A, B, C, should be somewhere here, because that's the way I must name it. A to B to C to D must form a parallelogram. So do D should be somewhere here, which I'm not sure. And how am I going to find that D? The way I've just showed you. Same thing happening here is going to be the same thing happening here. So I'm scared of drawing it because I don't know where it should be. If it should be in the fourth quadrant or in the third quadrant. Are you getting my drift here? I'm not sure where to sketch it. But how will I find that D? So from there to there, what happened? The same thing happens over here, or the other way around. Are you with me? I've done your homework some for you, just go write it. Okay.